Today's lesson, trapezoids. Today's date, this is lesson 5-4. And I asked the question, is a trapezoid a quadrilateral? And what did you guys say? Yes. It is a quadrilateral with exactly one pair of opposite parallel sides. A quadrilateral with exactly one pair of opposite parallel sides. Now, different people, different mathematicians will have a different definition from trapezoid. Instead of exactly, they'll say at least one. We're going to use this definition with exactly one pair of opposite parallel sides. Okay, are we ready? So, if I have this side is parallel to that side, I can put markings like this, yes? Now look at the lengths that I've made them. Are they congruent? Are they the same size, same length? No. If they were, then I would be drawing a parallelogram. Okay, so then I'm going to do this and do this, and there's my trapezoid. Okay, I'm going to call this A, B, C, D. And we're going to write some names down. We're going to have some names to the parallelogram. We're going to call AB base 1, and we're going to call DC base 2. Do you guys remember these in like 6th grade? You did this base 1, base 2 when you were looking for like area. Do you guys remember that? Yeah? Okay, these are called the legs. Leg and leg. Okay, so is this like a parallelogram where opposite angles are congruent? Is this one going to have opposite angles congruent? Can we look at A and C? Do those even look congruent? So is it still like a parallelogram? No. We're not going to look at this anymore and say opposite angles are congruent. What about consecutive angles? What was it for a parallelogram? Consecutive angles were congruent or supplementary? Supplementary. Let's look up here. Or do A and B add up to 180? There's the C shape. The arms of my C have to be parallel. Are these two legs right here parallel? So are these two going to add up to 180? No. What about these two? This is the arm of the C. These two arms right here, the bases are the arms of the C. Are those two arms parallel? Yes. So what can we say about A and D? They're supplementary is correct. Let's write that down. Angle, the measure of angle A plus the measure of angle D equals 180. The measure of angle A equals 180. Okay, there's another set. There's only one more set that also adds up to 180. What is it? Would it be D and C or B and C? Remember, the arms have to be parallel. Okay, I heard somebody say B and C. Can you guys see this crazy looking C shape here? Yes or no? Are the arms of the C parallel? Yes. So the measure of angle B plus the measure of angle C equals 180. You do need to know that because when you're solving on your worksheet today, when you're solving for x and they give you a trapezoid, and they give you like 2x plus 5 and x minus 7, and they ask you to solve, that's what you're going to do. So it's not all sets like it was in a parallelogram. It's just the two here that are connected with the leg. AD is connected with the leg, it's supplementary. BC is connected with the leg, it is supplementary. Is DC also supplementary? No. What about AB? No. All right, questions? All right, next one is a special kind of trapezoid. It is called the isosceles. isosceles trapezoid? Where have we seen isosceles before? Triangle. I'm just going to quickly review what's an isosceles triangle. These two legs are congruent. Do you guys agree? We call those the legs, which means what are these two angles called? The base angles are congruent. And what was this side here called? The what side? The base side. Okay, we're going to have something similar to that. We're going to have these two parallel lines here, which are not congruent. All right. So this would be, let me put my markings in here. This is the exactly one pair of opposite parallel sides, and it's isosceles because the legs here are congruent. Okay, so this is still base 1, and this is still base 2, and these are still my legs, but if it's an isosceles trapezoid, what can we say about the legs? The legs are what? Congruent. Okay, now this thing, okay, let me go ahead and label A, B, C, and D. This piece, A plus D, these two still add up to 180, and these two still add up to 180. Can you see that? Can you see the C shape and the arms of your C are parallel? Need you guys paying attention. Can you see the C shape and the arms of your C are parallel? Yes? So we can still say that angle A, the measure of angle A plus the measure of angle D still add up to what? 180. The measure of angle B plus the measure of angle C still add up to 180. That has not changed. There is one new piece that's only true for isosceles trapezoids, which we'll get to right now. Before I do, does everyone understand that these two are still supplementary? Yes? What about A and B? Are those two supplementary? No. Here's the arms of the C, and the arms of the C are not parallel. Okay, here's the new piece. Just like with an isosceles triangle, these base angles were congruent. The same is going to happen. Only thing is, with this, I have two sets of base angles. Can anybody give me one set of base angles? D and C. D is congruent to C. Why? Because they're base angles. Anyone else give me the other set? A and B. Do you guys agree? Why? Because they have that base there. Those are the base angles. All right, so angle A is congruent to angle B, and angle D is congruent to angle C. You will need to know that as well. All right, we're going to do a quick example before we move on to mid-segment. Find the missing angles. Find the missing angles. All right, I'm going to draw this picture like this. And I'm going to put special markings in there. I'm going to put parallel and parallel and congruent, congruent. Is this a trapezoid? Is it a special trapezoid? Yes. Does everybody see that it is an isosceles trapezoid? Yes? Okay. I'm going to give you some angle measures. Actually, I'm only going to give you one. let me label this first. This is A, B, C, D, and this here is 60 degrees. Find the measure of angle A, the measure of angle B, and the measure of angle C. All right. Don't blurt anything out. You're just working right now. I want you to look at this way and figure out again, don't blurt it out. What is angle D's base angle? Angle D does have a base angle. What is it? Look at your paper. See if you can figure it out. And base angles are congruent, so you're going to put a 60 there. Talk to the person next to you and see if you guys agree. I should hear talking. Talking. All right. Carrie, can you tell me what is angle D's base angle? A, does everyone agree with her? Yes? So what is angle A? 60 degrees. All right, so 60 degrees here. All right, I'm going to give you a little bit of time to think about how to find B and C. Well, first off, what do we know about B and C? Are those also base angles? Yes, those are also congruent. So once I find B or C, I know the other. Any thoughts from anyone? What is it? Can you tell us why? Let me repeat what he said first in case anybody did not hear. He said 180 minus 60, and he's going to explain why. Okay, can you be more specific? You said they. What's they?
It's like D and C make the C shape or whatever.
There you go. Do you guys see that? He said D and C make that C shape or whatever. Do you guys see that? And the arms of the C, bless you, the arms of the C are parallel, which means these are, what's the word that starts with an S? Supplementary. So 60 plus angle C equals 180. So he was saying subtract from 180. Do you guys agree? Subtract your 60. What does angle C equal? 120. So if C is 120, what else is 120? B. Any questions? Make sense? Okay, I'm going to move on now to mid-segments. Any questions before we move on? Okay, if you remember the last unit that we did when we did mid-segment, it works exactly the same. Bless you. Mid-segment. Okay, now this mid-segment theorem does not have to be an isosceles trapezoid. It can be any kind of trapezoid as long as it is a trapezoid. Now, do you guys remember the mid-segment for a triangle? Yes? It did that. Do you guys remember? So the mid-segment for the trapezoid is going to do the same thing. It's going to cut both segments in half. Can you guys turn that off, please? Thank you. Okay, so these two segments here are congruent. That's what a mid-segment does. It cuts each side length in half. Now, here's the question I have for you. Is it congruent across this way? Meaning, is it all congruent to each other over here as well? No. No, these two are congruent to each other, but only to each other, unless, again, it was an isosceles trapezoid. Okay, congruent here. Congruent here. I'm going to call this again A, B, C, D, adding in the M and the N for the mid-segment. Okay, mid-segment cuts AD in half and BC in half. Okay, let's do some labeling. This is base 1. This is base 2. And this in here is called the what again? Mid-segment. And it is on the test, so you want to make sure you understand. So let's just try a quick example of one of these, and then we're going to get working on today's worksheet. Okay. I'm giving you an example, but I haven't even given you guys the formula. Did anybody realize that? Sorry. We are going to do the example, but I need to come back and give you the formula first. Does anybody remember what it was for the triangle? Which one we doubled, the base or the mid-segment? We doubled the mid-segment to equal the base. Do you guys remember that? We doubled the mid-segment, and it equaled the base. We're going to do the same thing here. We're going to again double the mid-segment. And what is it going to equal if there's two bases? Base 1, base 2, or the sum of the two put together? It'll be the sum. Base 1 plus base 2. Double the mid-segment equals base 1 plus base 2. So very similar to what we've done before, only now we have another base. All right, we're going to use that here. Let me label what's given, 2x plus 4. And I am going to give you these markings in here so that you know it's either going to tell you it is a mid-segment or give you those markings. 3x plus 2. And 2x plus 1. And I want you to solve for x. Solve for x. All right. Kids are like, I don't know what to do. There's 3 of them. Which one's equal? None of them equal each other. Which one do I double? Base 1, the mid-segment, or base 2? Mid-segment. So double the 2x plus 4 equals base 1, base 2, or the sum of the two put together? The sum. 2x plus 1 plus 3x plus 2. What's the math word I'm going to use right there?
Distribute.
Distribute. Okay, I need everybody listening. I had a lot, and not necessarily from this class, but throughout all my classes, that on the last test distributed like this. Did I distribute correctly? No, there were a lot of kids that did this, and it was a little concerning. What mistake did I make? Good. 2 times 2 is 4x, but 2 times 4 is not 4. And a lot of kids did that. Be careful. What goes there? What is it? 8. Okay, 2x plus 3x is 5x. 1 plus 2 is 3. Go ahead and finish solving. Anybody have it? Is x equal 5? Okay, questions? All right, what I want you to do right now in the next few seconds, anywhere you have room on your paper, sum of the interior angles, each interior angle, sum of the exterior angles and each exterior angle. And I want you the best you can from memory. This is just a double checker for yourself to see if you have it memorized, because you will need it for tomorrow's quiz. So right now, the best you can. There was one easy one that had a 360. That was the only one that had no in. So from memory first. From memory first, and after you have it down, then flip in your notes and see if you have it done correctly. Okay. Double check in your notes, see if you have them done correctly. If not, please fill them in now. It's in your notes. I believe that's lesson 1. Is that correct? 5-1. Did anybody have all of them in your head already memorized? No one yet? Anybody get at least half? Okay, good. Making progress. You want to eventually have them all. Okay, what is this one here? The sum of the interiors. That's the one that is in minus 2 times 180. This one down here is the easy one. It is just, and what's nice about these two are exactly these two, but divided by, and that's the only difference. So you just rewrite them and then divide by n. Questions?